Okay, ready to go. Good morning, everyone. Still recovering or all recovered already from the party yesterday? Hanging in there? Okay. Yeah, I see some faces that I've seen yesterday, and it was a good party. I had a good fun time. So welcome to another session, and today and now we're going to talk about networking. I think it's one of the #1 questions we got, and also one of the harder pieces of doing failovers and failover testing. It's networking. So luckily today, Humair is joining us and is going to talk about best practices and networking for failover and failover test using NSX. So if you look at the agenda, I'll be introing a little bit, talk about the challenges of networking, and then the interesting stuff. Humair is going to take over, and he's going to talk about NSX. It's going to be fairly technical, a lot of diagrams. Luckily, he has this wonderful new thing where you can spotlight stuff. This is fantastic, and hopefully it's really useful because there's a lot of things you need to take care of when talking about networking. So we're going to end up with like a summary of the solution and some food for thought. Now, if we take a look at the challenges with networking in DR scenarios or DR test scenarios, there's a lot. So there's changing IP addresses. There's the physical network that you might also need to have available at the DR site. There's security policies. Are the security policies the same? Do you think about, security is a big part of networking, and that's the #1 thing that people most of the time forget by doing it in the DR side, because you need to make sure that all the security policies you have set in the main site are also active in the DR side. You don't want to lose some of the security measures you've been taking in your DR or in your production side once you go into a DR state. And the solutions you have nowadays and the more traditional solutions are really complex and make it really hard to basically make sure that the security policies are in place as well. We have the physical devices, we have load balancers, we have routers, firewalls, you name it. Now, not talking about all the ACL, DNS settings, application dependencies, you name it. So these are all challenges in the typical DR scenarios, in the networking of DR. Now, if we take a look at the traditional solutions, so right now, I see especially the top one. So I'm from Europe, from the Netherlands to be specific, so it's a tiny, tiny country. So we have connections, never an issue. We have like 10 gig L2 fiber connections all throughout the country. Now, so this is the #1 thing we see, but actually it's actually really complex doing L2. People think, oh, it's easy. No, it makes it actually a lot harder. There's VPLS over MPLS backbones, there's hardware-based solutions, there's software-based solutions as well, but these are all really costly. A lot of equipment, a lot of iron, a lot of metal. You have to make sure it's available in both sides, you have to manage it, you have to spread the policies, you name it. So it makes it really complex. So what we actually need and what we're actually looking for is a software-defined solution that needs to be simple. And we talk a lot about simplicity at Zerto, and I think adding the NSX layer on top of that, or actually making sure that's the backbone of your network, makes it really, really easy. We're looking for microsegmentation. That's really something that's happening nowadays as well. But actually, by doing microsegmentation, you're making it a little bit more complex on the DR side as well. So there's a lot of stuff we need to make that easy as well. We need flexibility. We need those higher level security constructs. Automation. I talk a lot about automation. I love automation. We should automate everything. But it's really important, especially in those DR scenarios. And easy DR testing. You don't have DR if you don't test it. That's at least how I think of it. Now, luckily, Humair prepared some great slides and is going to talk about how we can solve all of this with NSX. So please, big round of applause for Humair.
Okay, thank you, Gijsbert. That was great. So you saw there some of the challenges with traditional disaster recovery, right? And what I'm going to talk about here is how VMware NSX using some best practices in networking and security, can solve these challenges and then provide additional benefits. Okay? I guess before I get started, let me just give a quick introduction for those of you who don't know me. I'm a senior technical product manager in the network security business unit at VMware, and I've worked on, for the last 3 years, multi-site disaster recovery solutions, wrote the design architectures, published the design guides, and now I'm working on cloud and hybrid cloud architectures as well. Okay, so with that, let's go ahead and get started. So what I'm showing here is a design that's centered around a feature called Cross vCenter NSX. So Cross vCenter NSX was introduced in NSX 6.3, and it's basically a feature that allows for NSX networking and security across multiple vCenters. Now, typically customers who have solutions like disaster recovery will have multiple vCenters, right? Because the solution requires that, whether it's Zerto or some other disaster recovery orchestration tool. So how this works here is we have vSphere at each site. We have NSX Manager at each site. And we have a concept called primary NSX Manager, secondary NSX Manager. The rest are secondaries. You can have up to 16 NSX Managers, so you can have up to 16 sites. Okay? So from this primary NSX Manager, then, I can deploy what's called universal networks, logical switching, distributed logical routing, and also security universal distributed firewall. These are kernel-level modules within the hypervisor. So they go at about, close to line rate. And then you get this consistent networking and security across sites, configured from the primary. It gets synced to all the secondary NSX managers, all the secondary sites. Okay? And then I can deploy what's called ESGs here for my north-south routing. So universal distributed logical router is doing the routing east-west within the hypervisor, within the kernel, and then the edges are sitting, these ESGs are sitting at the edge doing north-south routing in and out of the software-defined data center. Okay? So here I have my active application sitting at Site 1, and it's using the ESGs at Site 1 for north-south routing. Okay, and I'm controlling that using routing metric. You can use OSPF, you can use BGP weight, and then you can use the corresponding routing metrics. Okay? So let's say this application fails or this entire site fails. Zerto will bring up the workloads at Site 2, and now I'll use the Site 2 ESGs. Okay, so just from this first slide that I'm showing you, you can see we're solving a lot of those traditional challenges that were mentioned in the prior slides, right? You have consistent networking. So when Zerto fails over your applications, you don't have to change IP address. What does that mean? This means you'll have faster, you'll be able to bring things up more quickly, right? You have consistent security. You don't have to manually synchronize security policies, right? You always know the policies will be the same. The system, the platform takes care of that for you. You have inherent automation, right? This is, again, first slide just to start, but already showing you right away the benefits of the software-defined networking with NSX. Okay, now along with that, because everything's in software, what does that give us? It gives us a lot of flexibility, right? Anytime you move things into software, you get a lot more flexibility. So here I'm showing the design I just showed you, where I have my active application here, my standby here, I have my logical network spanning both sites, and the active application is using the Site 1 ESGs. With a click of a button very easily, I can deploy another UDLR, additional logical networks, and now I can deploy my active application here at Site 2, and my standby at Site 1, and this active application is using the Site 2 ESGs. So here I've basically done bidirectional DR, where I'm using the resources of both data centers. Okay. Another design I can do is active-active, where I have an application that's spanning both sites. So I have my logical networking spanning both sites, but you can see I have apps both at Site 1 and at Site 2. Now, for both of these apps, or for this app, whether it's at Site 1 or Site 2, I can control how the traffic goes out north-south via routing metric, as I mentioned. It's actually a small typo here. Both these are the same app here. I say app A here and app B, but they're the same app. Okay, so they're just spanning both sites. So right now I'm saying, okay, all traffic goes out the site 1 ESGs. Now I can also configure it in NSX with a feature called local egress, where if it's at site 1, it goes out to site 1 ESGs. If it's at site 2, it goes out to site 2 ESGs. Now, if I were to vMotion, or let's say I had a partial application failure and Zerto does that recovery to site 2, it'll automatically use the ESGs local to its site. Okay? So you can see there are a lot of flexibility in terms of what you can do. And what I want to talk about next is some of the additional capabilities we added specifically for disaster recovery, starting with security. So we're very familiar with using IP addresses for security policies. It's not the best practice, right? It's not really close to the application, doesn't really have too much tie-in with the application. IP addresses were really truly never meant to be used for security. It's just the way things ended up being, right? But if you think about it, IP addresses don't really tie or have any meaning to the application, right? I don't really know what 10.10.10.10 can't talk to 11.11.11.11 means, right? I don't know what that means. But I know what it means when I say VMs that have a security tag of web can talk to VMs that have a security tag of database. It's intuitive. It's closer to the application, right? It's not confined with these IP addresses and subnets, right? And that's what we really want here. Additionally, when I have my workloads come up, I want them placed automatically into some security group based on these security tags or these other types of identifiers, not really IP address, right, which are constantly changing. I can put a security tag on a VM, IP address can change all at once, but the security policy will be the same, right? So here we introduced a concept called universal security tag, and let me kind of walk through this flow. So if you want to use universal security tags, this is kind of the flow you go through. On the primary NSX manager here, before I go to that, let me actually explain this diagram a little. I have universal networks on both sides, right? Primary NSX manager, secondary NSX manager, my universal controller cluster, I'll talk about a little bit later. It knows the entire state of the network. It's where all the intelligence is. But the main concept here for the security discussion is I have logical networks spanning both sites, and you'd have your Zerto sitting at both sites as well, okay? First thing I do, go to my primary NSX manager. I configure something called unique selection criteria. You have 3 options here: virtual machine UID, BIOS UID, and virtual machine name. And what this is basically when Zerto does that disaster recovery orchestration to the secondary or recovery site, those tags have already been synced and they're just sitting there, okay? So now NSX Manager needs a way to know what VMs belong to what tags. And this is what this selection criteria is. So you can use either any one of these. We give the option because customer may have different tools, and based on their disaster recovery orchestration tool or their environment, they might need to use something specific. And for most cases, the first one, virtual machine instance UID, is sufficient. For example, when Zerto is doing this replication, it replicates that UUID. So when the workloads fail over, the tags will automatically get applied to the correct VMs based on that UUID. Okay? You can also use virtual machine name if you have VMs with unique names, right? Because then that can be used as a unique identifier. So first I do this, right? Second, I create the tag. So I create a security tag, select this checkbox here to mark it as universal, and then that tag automatically gets synced to the secondary site or recovery site, okay? Now I attach that tag to the VMs that I want that tag to be associated with on the primary site. So now when the Zerto does that disaster recovery orchestration, VMs come up on the recovery site, tags are applied to the correct VMs based on that unique identifier. They're automatically placed into the correct security groups because of the security tags, and those security groups are used in the policies. So you get consistent policies using these higher level advanced security constructs, right? Another great benefit of NSX. Now, I'm talking a lot about NSX here, but the concepts I'm talking about are best practices in general for networking and security. Best practice is you don't want to be reliant on IP addresses. You want things dynamically defined and placed into the right groups and have that consistent security policy. It's just NSX is following those best practices, right? It's solving those problems, okay? Another feature specifically for disaster recovery is this feature we came out with called CDO mode, or controller disconnected operation mode, okay? So as I mentioned, controllers know the state of the entire network. It's the control plane, okay? So they know what VMs sit on what logical networks on behind what hosts, and they can communicate that to all the other hosts and all the other environments so things can communicate. And these controllers sit out at the site of the primary NSX manager. They sit at a single site, right? But what were to happen if the site were to go down, where the controllers sit? Now, there's complete separation of control plane and data plane in NSX. It's another benefit. So data plane's already programmed, so things will keep forwarding. And controllers, you know, by definition, the control cluster is already resilient, right? Because it's in a cluster. So by definition, clusters provide resiliency. And then there's vSphere HA providing extra resiliency. But let's say here in the rare case, the entire site goes down, what were to happen? As I said, the data plane will keep forwarding, but there is a corner case, and this corner case is what CDO mode addresses and what I'll talk about next. So here, with no CDO mode, I have two sites. Imagine these are two sites I'm using for disaster recovery. I have the control cluster sitting here at site 1, and there's no CDO mode right now. I have a logical network, and the VMs are both sitting at site 1. No CDO mode, with controllers up, things work, right, as expected, because this host knows where both of these VMs sit. They sit right on the same host. All the information is in the control cluster. It gets that information. Things can communicate. Everything works. Now, what if the controllers in this entire control plane were to go down? Again, things will keep working because data plane's already programmed, right? Now, what about this specific scenario where the controller cluster is down, control plane is down, and the second VM now moves to host 2? This is where you would see a data plane outage. The reason is this VM now moved to host 2, but this host can't communicate to the controller cluster, hey, this VM's now moved there, and it can't communicate that to host 1. So host 1 doesn't know either. So now this guy doesn't know this VM is moved to host 2, and that's where you have the data plane outage. And this is where CDO mode tackles this problem. So you can see we're really looking at all the specific corner cases and making this a lot more robust, the solution a lot more robust. So we enable CDO mode on the primary NSX manager. And what this does is in the back end, it creates something called a CDO logical switch. Just think of it as L2 domain, L2 over L3, right? And all the hosts join that logical switch and create what's called a global VTEP list. What's a VTEP? It's basically the termination point for VXLAN, right? So now this global VTEP list is distributed to all the hosts, okay? So now let's go through this example with CDO mode enabled, that failure scenario. VM1, VM2, again, on the same host, complete outage of the control plane, and now VM2 moves to host 2. Things keep working. How does this happen? Because the host uses that global VTEP list, because I enabled CDO mode, and it sends the BUM traffic, broadcast, unicast, multicast traffic, to all hosts in that CDO logical switch. Okay, so communication can keep working, right? Okay, so what I want to talk about next is how we can also do DR to the cloud. So far, what I talked about is, you know, all the benefits, right? The traditional problems we're solving, networking, security, you know, we have inherent automation, how we made things more resilient, the flexibility in design. And now I want to talk about how we can also do DR to the cloud. So here we have site 1. This is my on-premise site. And let's say we have another site 2 sitting in the cloud provided by VMware cloud provider. Let's say, for example, IBM Cloud. I can have direct connectivity between the two, and we have a lot of customers doing this. And because I have that direct connectivity, I can do L2 over L3 via cross vCenter NSX, right? So this is VXLAN. It's not L2, it's L2 over L3. So I've completely routed network in between. And because of this, now I can extend my logical networks natively, VXLAN across both sites. And I can also have that consistent security across both sites, leveraging these higher level security constructs like security tags, okay? So my active application is at site 1 now, and my standby is in the cloud. Now, this is one design using that cross vCenter NSX feature. But what if you don't meet some of the requirements to deploy cross vCenter NSX, or you just don't have NSX on-prem? Right? What can you do? Well, there's alternative designs, and we have customers, we have actually cloud providers doing this as well. Okay? So here we have site 1. This is my on-premise environment. Let's say there's no NSX, so it's all VLAN backed. And here I have another environment in the cloud, and could be using a VMware cloud provider again. It could be IBM Cloud, could be a provider like iLand or another provider. Okay? So here now I'm connecting the two with IPSec. So in the cloud environment, they'll typically want to be leveraging NSX because these are cloud environments. You want that automation, multi-tenancy, all these capabilities to easily bring things up and have tenants come on and onboard, right? You want that. You don't want to be relying on this traditional way of doing things. Now, customers may have these VLAN-backed networks, right? So they can use IPSec, NSX here. You can use the ESG, that edge gateway I talked about earlier, where you can enable the IPSec, right? And then on-prem, you can use any IPSec compliant device. It could be Cisco, it could be Juniper. If you do have NSX on-prem, it could be the NSX edge as well. Okay? So now I have my active application on-prem, standby in the cloud. You can also leverage L2 VPN, where I'm extending the L2 network to the cloud. And use cases here might be partial application failure or migration, right? So in this scenario, I have L2 VPN server enabled on my edge in the cloud. Again, the ESG, they have NSX running here. And we also offer a standalone NSX edge appliance for customers who don't have NSX on-prem. And you can deploy that in HA mode for additional resiliency there as well, okay? Or additional high availability there, okay? So now you can leverage L2 VPN with your active on-prem and your standby in the cloud, okay? So what I'm going to talk about here is next is architecture for multi-site, and disaster recovery falls into that. Let me just check the time. I think we're at 12:15, right? Okay. I think we're good. Otherwise, I was going to skip this section. But before I go into this, any questions? Okay. Feel free to stop me along the way, ask any questions if something is unclear, or if you want to address something specific, okay? So let me go into some of the architecture so you can kind of understand how we're doing this, and then what I'm going to do is wrap it up by bringing some examples of Zerto into the mix and showing some of the capabilities around testing your disaster recovery solution. But I want you to really walk out of here understanding exactly how we're doing this, how you can leverage it, some of the different designs with networking and security, and then how Zerto can be leveraged as well to kind of enhance this disaster recovery solution. Some of that you should already know from the prior slides, right? The consistent networking and security, but there's additional things we're going to get to here. Okay? So network architecture, how does this work? So we have 3 vCenters here. These are sitting at 3 different sites. We have corresponding NSX managers at each site. Initially, these are all in standalone mode. And as I mentioned earlier, what I do is I come to this guy and I make him primary. Then I give him the credentials of these other NSX managers, and then these guys become secondaries. So when this guy becomes primary, a service starts on it called Universal Synchronization Service. This service syncs the universal objects to the secondary NSX managers, okay? Now, from this primary NSX manager, I deploy the universal controller cluster into the inventory of that local vCenter. Okay, and then the universal synchronization service gives all the other NSX managers this configuration so they can connect to this controller cluster.
Is there a latency requirement between the primary and the secondary NSX managers?
Yeah, so the question is there a latency requirement? So here the latency requirement is 150 milliseconds, which falls in line with enhanced vMotion. So if you're familiar with vMotion, the requirement for that is also 150 milliseconds. Okay. All right, so now the NSX managers connect to this controller cluster, and they also send that information down to the host via a message bus. Each of these managers have a message bus connection, TCP connection to the hosts, right? And they send that config down. So now the hosts know how to connect to the controllers as well. So now everything's connected to the controllers, and I can create a universal object on the primary. It gets synced to the other NSX managers and pushed down to the hosts. Okay? So that's how that works. And if you look at it here, remember I can only create the universal objects on the primary NSX manager, right? And there's logic to a lot of this. I mean, if you're thinking about it, like I said, we're implementing, I mean, I'm talking about NSX here, but when you're thinking about multi-site, you're kind of thinking about the issues, the challenges. When you're creating objects and they're going across site, you want like one centralized place of management so you don't run into collisions and things like that, right? So here you're always configuring it on the primary NSX manager, create my universal logical switch, gets stored locally, pushed to the controller cluster, gets synced to the other NSX managers at the same time. Now, a local logical switch I can create on any of these guys, let's say this last one here, gets stored locally, also pushed to the controller cluster. So you can kind of see this universal controller cluster as a shared object holding all of this information. Okay. Now, the security architecture, you'll notice I didn't mention the security architecture there. It's completely independent of the networking architecture. So it is possible that even for DR, you know, if your customers using Zerto, perhaps they're just concerned about the consistent security. They can leverage NSX just for that and just deploy for the security architecture, the security design. Or they can do both the networking and security, which provides the full value and solves all those issues, right? So here again, I have my primary and secondary sites, primary NSX manager, secondary NSX managers. I have my message bus from each NSX manager to my host. I create my universal distributed firewall rule on my primary NSX manager here. It gets stored locally. It gets pushed down to all its hosts via the message bus. At the same time, it gets synced to the secondary NSX managers, which store it locally, and then also push it down to their respective hosts. So now I have consistent security across all of my sites. Right? This is how that's being achieved. And if you look at the value add here, right? Look at this example. This kind of explains, you know, the benefit. Here I have a 3-tier application, logical network spanning both sites. And let's say initially the web and database are talking to each other. I want to prevent this communication. I want the web to go through the app to be able to talk to the database. So I create a universal distributed firewall rule saying web can't talk to app. Now, let's say I either vMotion or I have a partial application failure. Right? Zerto recovers this workload. Well, that policy stays in effect, even if it goes across sites, across vCenters, because of this universal distributed firewall rule. And even if the entire application or a database VM moves to the secondary site, again, that policy remains consistent. Policies are move with the workload, right? Not easy to achieve using traditional models, right? When you move something, there's a whole bunch of configuration you have to do, right? The platform takes care of everything for you here. Okay, so what I showed there was capability with universal distributed firewall native to NSX. You can also leverage third-party advanced security for disaster recovery in your solutions, such as Palo Alto Networks. Now I deployed Panorama into the management layer where my vCenter and NSX manager sit, right? And they're doing HA. So my advanced security policies in Palo Alto are synced to my standby Panorama, right? And from Panorama, you can see it's the active guy is registered to both NSX managers at each site. So I can, from this active guy, also push down these service VMs that actually do that advanced security, whether it's deep packet inspection, URL filtering, anti-bot, so on, right? That's happening in these SVMs deployed from the active Palo Alto networks, Palo Alto Panorama, okay? So now from Panorama, I can also automatically generate my redirection policies by clicking this auto button here, auto steering rules, okay? And it's automatically creating these based on the policies I defined in Panorama. It creates these redirection rules, and then you can push these down from here to the service VMs, to the host, to the ESXi hosts. Okay, so then specific traffic will be redirected. You could say all web to app traffic redirect to this SVM and do that deep packet inspection or whatever you like. Okay. So now I have this security management layer at top, right? Using DFW for up to L4, and application level security is being handled by the Panorama. And I push all my policies down from the active Panorama. Again, DFW down here is taking care of everything up to L4, and Palo Alto Networks is doing all the advanced security with those service VMs. Okay, now if this guy were to fail, the standby will take over. I can update and edit from the standby and push those policies down also. Okay. All right. So 1203. Okay, I think we're good here. So now I want to talk about a couple designs. So this first design is multi-site, multi-vCenter, active passive site egress. So I'll kind of explain this in a minute. But here I have logical networks spanning both sites. I have my primary NSX manager, secondary NSX manager, vCenters at both sites, right? It's a multi-site environment, okay? And basically what I'm saying here is workloads at both sites will use only one set of ESGs, either at site 1 or site 2. That's why I call it active passive site egress, okay? So let's look at how this works here. So this control VM, it's an appliance, is basically the control plane for the UDLR. It's peering with these ESGs at both sites, learning the routes. And then it sends the best route to the controller cluster. I control that via routing metrics. So I give these ESGs a better routing metric. If I'm using BGP, for example, I give them a higher BGP weight. So it sends the best route to the controller cluster. Controller cluster then distributes that information to all the hosts, and hosts know to use these ESGs at site 1 for north-south traffic. Now, if these guys were to go down, this control VM will say, okay, best routes are now at site 2 ESGs, update the control cluster. Control cluster will now distribute those routes to the host, which will now use the site 2 ESGs. So you can see how that works. Again, I can have active workloads at both sites, but for north-south egress, I can use just one set of ESGs. This simplifies the design a bit. Okay, so now if this guy were to go down site 1, obviously Zerto can bring up these two workloads here at site 2. They'll be using the site 2 ESGs. There's another design called active-active site egress. Everything's the same except it's active-active site egress. So you can see here, pretty much it's the same design. Few key differences. I have a separate control VM at each site, peering with only the local ESGs, and I have something called local egress enabled. I'll talk about that in a minute. As I walk through this workflow, I'll explain that local egress. So same thing's going on. The control VM at each site is peering with the local ESGs, learns the best routes, and sends the best routes to the controller cluster with something called the local ID. So this local ID is basically a 32-bit unique identifier, and by default, it's that of the local NSX manager. And the hosts have that same unique identifier, okay? So keep that in mind. This is going to be used like as a filtering mechanism, as you'll see later on. Now, at site 2, same thing's going on. This control VM's peering with the ESGs, sends the best routes to the control cluster with that local ID, which is 32-bit unique identifier of its local NSX manager, and hosts here have that same ID by default. Okay? So now this control cluster has information on both sites, about both sites, right? So it starts distributing those routes. And it distributes those routes to the hosts who have a matching local ID. So the routes it learned at site 1, it distributes only to the site 1 hosts that have that same matching local ID, and same thing for site 2. This is how you get localized egress at each site. So even if the app's stretching both sites, once the VMs at site 1 will go out site 1 ESGs, VM at site 2 will go out site 2 ESGs, right? So this is another deployment model. Okay, now if site 1 were to go down, obviously Zerto will bring up the workloads at site 2 and go out to site 2 ESGs for north-south traffic. Okay. Okay, so there went through a lot there pretty quickly, but you should have a good at least foundation now of the benefits, the designs, the flexibility, the possibilities, and the different deployment models. And what I want to talk about here is a little bit about how Zerto and NSX, some additional benefits they provide by combining these two together, right? So first of all, what's required here? What are the components that are required? Well, for compute and networking, you need at least vSphere 6.0 because that's where cross vCenter vMotion was introduced, where you can vMotion across vCenters. And then you need at least NSX 6.2 or greater because that's where cross vCenter NSX was introduced, where you get that networking and consistent networking and security across vCenters. Okay? And then you need a DR orchestration tool. It could be any DR orchestration tool. Of course, in this case, it's Zerto, right? So now for the replication, again, you can do array-based replication. There's lots of different replication things out there. In this case, we're leveraging VM-based replication with Zerto, right? Okay. So let's take a look at this. So here again, I have the same design I showed you before, multi-site environment, vCenters, NSX managers at both sites, networks spanning both sites, L2 over L3, right? So I've configured all of this. I have my primary and secondary NSX manager here. I have my controller cluster down here. There's only 3 controllers. This is just showing you the status of each controller to each NSX manager because you have 2 NSX managers and 3 controllers. Shows you 6 rows there. So everything's up and functioning. And I'm leveraging my security tags as well for the security. And then I am also leveraging Palo Alto Networks for advanced application level security. Now, I also deploy my Zerto Virtual Manager in this management layer, right? So I have my vCenter, NSX Manager, Palo Alto, and go ahead and deploy Zerto Virtual Manager into this management network for my disaster recovery orchestration. And from there, I deploy my Zerto replication appliances into the clusters, the compute clusters, right? So now I have my active application sitting here at site 1, and it's leveraging the site 1 ESGs for north-south. Distributed router is doing the east-west routing. ESG is doing north-south. I have my Zerto Virtual Manager, my Zerto replication appliances, right? And my Zerto Virtual replication appliances are providing that replication, and I have my standby application here. Notice IP addresses are exactly the same. Security policies are exactly the same. Now, application goes down or site goes down. My Zerto will basically bring up this application at site 2, my virtual protection group here, and based on the boot order I've configured, ideally I want to bring up database, then app, and then web. So when my web front end comes up, all the back-end services are already taken care of. And the security tags are applied based on that unique identifier. So you get that consistent security. So you can see here, no IP address change, security policies are consistent, and everything's good to go, right? That's how the solution works. Again, east-west routing, DLR, north-south ESG. And if my ESG here is still up, I can have a design where I still leverage that because maybe I just want to move this, figure out what happened here. If it was just an application failure, move this guy back. If it's a complete site outage, maybe then I'll say, okay, failover and use this site 2 ESG. Okay. Now, one of the best things about the solution one of my favorite things is this capability and the ease of DR testing, right? Very not easy to do when you have a production app up without taking some downtime in the traditional sense, right? And you see all these outages all the time and you wonder what happened. Did they not have a DR plan? Typically, from what I've seen, they had a DR plan, but they never really effectively tested it, right? And NSX and Zerto together make this very easy to do. So here within Zerto, you can see from a VM level, you guys are probably very familiar with this. I can select my production network when an actual failover happens, or if an actual disaster happens. I can also select a test network. In both of these cases, I'm selecting NSX networks that I've configured, right? So I've created a separate test network and a separate production network. My production app is running on this production network. It's going to fail over to the same production network, right? That's what I want. But then I created a separate test network to fail over to when it's testing. But the cool thing here is it's exactly the same IP addressing scheme, exactly the same security policies, but they're isolated. Okay? So you can see here I've configured for my 3-tier application, to fail over to the production, and then when I'm testing, fail over to these test NSX logical networks. So now here within vSphere, you can see when I do a test, it appends this text called testing recovery. This is important to note because if you're using that unique identifier based on VM name and you do a test and then it appends this testing net recovery, obviously it's not going to match, right? Because you're using that as a unique identifier. So you have two options there. You can either have that recovery run a script to remove this appended text, right? Or you can just use a more simple approach and just use that VM unique identifier, right? Which Zerto will replicate. Okay? So here I have a production network that I've created, and I have my active application here. Now for testing purposes, very easily, again, click of a button, I can create a reproduced network, test network. Test UDLR test networks. Notice the IP addresses are exactly the same here. Now from Zerto, whenever I run that failover test, it'll bring up those workloads at my recovery site on these test networks using the same IP addresses, using the same security policies in an isolated network, right? Without any disruption to the production application. And I can test here. I can test here the connectivity between the tiers and so on, test my application, routing, everything, make sure the security policies work. Again, using the same IP addresses and security policies without any disruption to my production app. That's the real value, one of the core values here with everything else I've already mentioned. Okay. Now, last thing I want to cover here is we talked about recovery of the applications. And we're using a platform here for all of these benefits, and that platform is NSX. So what about the NSX component recovery, right? You also have to think about that. So here, let's say the site 1 goes down. What do I need to do? Well, remember, I have NSX managers at both sites. So I have my primary here and secondary here, and they're syncing things, right? They're syncing the universal configurations. So when this primary site fails, all I have to do here is, and you can automate this, include this in your disaster recovery workflows. I basically make this secondary NSX manager primary. From there, I redeploy the universal controller cluster. I click a button to update the controller state because there's some configuration that needs to be updated. IP addresses have changed and so on, right? And redeploy the control VM at site 2, right? This is the control plane for the UDLR. Now, if you're using that other model I showed you, local egress, where you already have a control VM at both sites, obviously you can skip this last step. But this is what would be required from the NSX component recovery. Now, keep in mind, data plane is always already programmed, but this is just so you can get control plane management things back up, everything back up and running at site 2. Okay? So that's pretty much it. Let me hand it back, and hope that was useful and that gave you guys some real insight into some of the, not only the best practices of what you would really want in a disaster recovery solution for the most optimal performance and getting things back up and running, but also how NSX works and can help you do that. Okay.
Yeah, thank you very much, Humair. I'm going to skip. The last section, time-wise. We're between lunch now. I mean, lunch is starting now. If you have time, guys, I would like to open it up for questions, actually. And I'll put up the summary slide. So, oh, there we go. The summary slide as well. So if you have any questions, feel free to ask them. I do want to give some time to ask questions. Otherwise, I think Humair will be here for the next couple of hours. So you can reach out to him directly, or I'll be there as well. So let me know. I think everybody's hungry. Oh, there's questions right over there.
Just to take advantage of local egress in a partial failover, you have your, say your split between hosts that are in two different sites. Can you still perform advantage of that?
You can, yeah, you can. Sure. So the question was, can you still take advantage of local egress if you have partial application failure? You can, you don't have to, but you can. Like for example, let's say if your web application fails over, like say you have one web VM at site 1, one web VM at site 2, VM failed over to site 2. You can have it go both out to site 1 ESGs, which is probably what I would recommend for simplicity, because most applications, I mean, customers deploying this type of application with pretty high bandwidth, low latency connections. I mean, this is a pretty advanced solution. So latency will be minimal. I mean, I haven't seen from customers any issues there. And that'll be the most simple approach. You can use local egress as well. So when that VM fails over, you can say, hey, use the site 2 ESG. And we handle that local egress. But you have to keep in mind, you have to then handle the ingress too. And once that traffic leaves the NSX domain, right, then obviously we don't have much control over it. So you have to kind of implement some design or solution to bring that traffic back in the same way so you don't get asynchronous traffic flows, right? So if you want to do that, you can do that. And we have people doing that. We have customers doing that. And you can leverage, and I've shown designs like this. I didn't show it here, but if you go to YouTube, you can just Google NSX, F5, GSLB design, where it sees the local traffic and routes it through using GSLB back to the local destination for ingress.
So you have load balancers on both sides.
Yeah, you have basically this GSLB component, which looks at, you can do region-based load balancing. So it looks at where the client is connecting from, and based on where the client is connecting from, it load balances to the local site. It's a more, I would say, complicated design. That's why, for simplicity's sake, typically I would recommend the first approach, active-passive, because it simplifies things, and you don't have this additional overhead. So as long as that meets the requirements, I would go with that. Now for DR, like for Zerto, if you're doing complete disaster site recovery, you don't really need an active-active design because the whole site's down. So it's going to just start using the site 2 ESGs anyway, unless you're doing specific things like you mentioned with partial application. Okay.
Any other questions? No? Then all ready for lunch. Enjoy.